5.1 is derivatives of exponential functions, and in particular we're going to look at y equals e to the power of x. So one of the fundamental limits of calculus is this wonderful limit here that says that as x approaches infinity, 1 plus 1 over x to the power of x approaches a very special number called e. Now, you would probably think, if you were just trying to do this on your own, that this limit here, if I didn't say it was e, you'd probably think that this should approach 1. The reason being is that if I divide 1 by a very large number, this should be approaching 0, right? 1 divided by 100 billion, it's going to be very, very small. And then I'm raising that to a really large number. So 1 to any power is 1. So y is 1 over 1 plus x to the x equal to e. So if you take out your trusty calculator, and I want to show you how you would get close to this number. So let's say I said I'm going to do 1 plus 1 divided by 1 with 1, 2, 3, 4, 5, 6, 7 zeros. And I raise that to the power of 1 with 1, 2, 3, 4, 5, 6, 7 zeros. You'd see that I get a number 2.718281693, which is getting pretty close to the actual value for e. So now that we've proven that e is a very special number, you also are going to find out that e has some other very special properties, and that is that it is the only function that has itself as its derivative. So the derivative of e to the x is simply e to the x. So if you look at a graph of y equals e to the x, so remember it's just saying this big number raised to the power of 1. So to the power of 0, of course, everything is 1. And if you look at the slope here of this function at 0, you'd find that, at when x is 0, y is 1, the slope is 1. And when we have a height of 2, the slope is actually 2. And a height of 4, the slope at 4 will be 4. So the basic rule is that the derivative of e to the x is e to the x. However, of course, there are some other little parts you have to look out for, and that's when the exponent is not simply x. If I have some other little function up there, like this number, minus 3x, then we have to also multiply by the derivative of that exponent, which is it's a composite function here, right? Okay, so let's take a look at this one here. Y equals the derivative with respect to x of e to the minus 3x. So all I have to do is write out what was there first, e to the minus 3x, and then times the derivative of the exponent, which is going to be minus 3. So that gives you minus 3 e to the minus 3x. Okay, let's take a look at this one, and then we'll do this is just warming you up. Okay, so the derivative of e to the root of x, I write e to the root of x out first, and then I take the derivative of the root of x. So the root of x, as you remember, is x to the 1/2, and if I take the derivative of that, I would 1/2 x to the minus 1/2, which is 1 over 2 square root x. So that's going to be 1 over 2 root x. And if you write it out nicely, because you want to make it pretty, you would get this for your answer. Okay, so let's go on to some other questions. Now, if your teacher is teaching this to you before you've done curve sketching, I'm still going to do some of the curve sketching with this lesson for those who have already covered that. So find the coordinates at which the tangent is horizontal. Now, even if you haven't done curve sketching, you do know how to find a point where the tangent is 0, and that's simply by setting the derivative equal to 0. But first, we need to find the derivative. So you must remember that something like this is going to require the product rule because we're multiplying two things. Remember, this isn't just a constant. This is a function raised to a power. So when I do the derivative, now again, some students have suggested that I'm doing mine backwards, but you can do this either way, and this is the way I learned it. So you'll still get the same answer. I always do the first times the derivative of the second. So the first times the derivative of e to the x is e to the x, plus the second, which is e to the x, I'm going to write it here, times the derivative of the first, which is going to be 4x cubed. Just so I had these in order. And then, in order for you to set this to 0 and solve, you would want to factor, right? So what's common to both of these terms? Well, I have x to the 4th, x3, so I'll take out an x cubed e to the x. So x cubed e to the x, and that leaves me with an x plus 4. Okay, so if I'll just write, so for critical values, we're going to set y prime equal to 0. So I get 0 equals x cubed e to the x times x plus 4. So you can see from here there's only two ways that I can make this 0. And that is if this is 0 and if this in the brackets is 0. Because e to the x is never 0. Take a look at our diagram of it here. It has a horizontal asymptote, right, as do all other exponential functions. So I had the asymptote y equals 0. So this is never going to be 0. So that means that x would be either equal to 0 or minus 4. So if I have 0 and minus 4, and I want to know if I want to know if they were minimums or maximums, and that would be if you've already taken curve sketching, I would write out my first derivative number line and plug in 0 and minus 4 and check to see if the slope was positive or negative on either sides of these. So if I go to the left of negative 4, let's say I plugged in negative 5 in here. A negative cubed is negative. This is always positive, and this would be negative. So I have two negatives. That makes a positive, so that's positive slope. And if I go between minus 4 and 0, I choose minus 1. So this would be negative, positive, positive. So that makes this negative. That shows we have a maximum here. And then if I go to the other side of 0 and I plug in positive 1, positive, 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 everything's positive, I have positive slope, which means this will be a minimum. So I need to know the coordinates. You were asked for coordinates. So I need to know minus 4 and what is the y coordinate when x is minus 4. So when x is minus 4, I would have minus 4, well, minus 4 to the power 4 is 256. 4 times 4 times 4 times 4. And e to the x, I would have e to the negative 4 or e to the power 4 in the denominator for a positive exponent. So this was a maximum value. And the minimum value would be when x is 0. Y is also going to be equal to 0, and that would be my minimum. So remember, watch out for questions that ask for coordinates. Make sure you're finding the y as well. Okay, moving on to another practice derivative here with our e to the x. I have y equals e to the x times x to the minus 1. Now again, remember this is a product rule because I have something times something. Now this could also have been initially written as e to the x over x, right? So if I'm going to use the product rule on this one, well, we're going to look at two ways. Let's use product rule, and we're going to use the quotient rule as well. See which one is easier. Okay, so if I do the product rule, I would say the first times the derivative of the second. That's going to be negative x. I've got to put a bracket here because it's times negative x to the negative 2. So that's first time derivative of the second plus the second, that's x to the minus 1, times the derivative of e to the x, which is e to the x. So if I go to simplify this now, I would say I can take out e to the x, and I'm left with negative 1 over x squared. And I have plus 1 over x. And in order to simplify this, and I think you might find that a lot of times you're expected to put this in another form. Like if you stopped here, you'd probably look in the back of the book and say, what did I do wrong? And you didn't do anything wrong, you just missed that one little step farther. Okay, so I have e to the x, and to make a common denominator here, I would have to make this times x. I put it in a little pink here. So I do x times x. So that's going to give me minus 1 plus x, and both are over x squared. Or even better yet, I'm going to write it as x minus 1 over x squared. So just change the order here, kept the same denominator. Okay, so let's look at using the quotient rule for the same question. So the quotient rule, and I'm using this right from here. So I'm bringing y prime, so I'm doing the ho d high rule. Love it, right? So I do ho, d high. Derivative of the top is e to the x minus high e to the x derivative. So high d ho is going to be e to the x times 1 over ho squared. And if you take out an e to the x, oops, I take out e to the x, and I'm left with x minus 1 all over x squared, which is much easier, and I didn't have to find a common denominator. Okay, the next one I want you to look at is this one here, y equals e to the x over 1 minus e to the 2x. Okay, so take a deep breath. You need it when you have a cold. Okay, so now I'm going to do the ho d high rule. So ho, I hope you've learned the ho d high rule well, because it's so easy when you do ho d high, derivative of e to the x, e to the x, yay, I'm so smart, minus high d ho. Oh, well, the derivative of the bottom here, derivative of 1 is 0, and the derivative of minus e to the 2x is minus e to the 2x times 2. Okay, did you get that? So I did e to the 2x minus e to the 2x times 2 all over ho squared. 1 minus e to the 2x quantity squared. Okay, so if I expand this, or better yet, let's take out an e to the x first. So let's take out an e to the x because they both have that right here. So I'm going to have 1 minus e to the 2x, and this here was minus 2e to the 2x. Minus it means plus 2e to the 2x all over 1 minus e to the 2x squared. And finally, I have e to the x minus 1e to the 2x plus 2e to the 2x is just going to be plus e to the 2x. And I'm still over 1 minus e to the 2x squared. Okay, so there's a nice little product rule for you. Okay, so the last question I'm going to do is going to be an analysis of curve sketching of this function e to the negative x squared. So if you haven't done curve sketching, at least follow the rules for the derivatives, and then you might need to come back to this later when you've done curve sketching of chapter 4. Okay, so I said find the x and y intercepts, asymptotes, max and minimum values, points of inflection, and sketch the function of y equals e to the minus x squared. Okay, so let's start. So for x-intercept, set y equal to 0. And as you know, I can never have, if I put 0 here, nothing makes, for x-intercept, set y to 0. Yeah, 0. I can never have a 0 because this is, you don't get 0. E to any power is never 0. So no x-intercept. My brain isn't working so well today, so forgive me. So for y-intercept, set x equal to 0. So if I put an x as 0 here, I'm going to get y equals 1. So that's my y-intercept. Y-intercept is 1. Okay, intercepts are done. How about asymptotes? Well, there's no vertical asymptote. Is there a horizontal asymptote? And you should know that, yes, there is, because as x approaches infinity, this is going to approach 0. So the horizontal asymptote is y equal 0. Okay, now we're ready to do some derivatives. So let's take the first derivative, y prime, the derivative of e to the negative x squared. So e to the negative x squared. So remember, you just rewrite this one and then do the f prime x. So this is going to be minus 2x. So there's my first derivative, minus 2x. Let's write it up this way, e to the minus x squared. Okay, so let's do the second derivative as well while we're at the derivative stage here. So y double prime is going to be the first. I'm going to write it out above here for you. So the first times the derivative of the second, just in case you're doing yours the other way, derivative of e to the minus x squared is going to be minus 2x e to the negative x squared. I'm just doing it all in one step now. Take the derivative, put it in front, rewrite this. Minus 2x e to the minus x squared, and the second, of course, was e to the minus x squared times the derivative of the first, which is minus 2. So if I expand that now, I would have 4x squared e to the negative x squared minus 2e to the minus x squared. And I'm going to take out a common factor here of e to the negative x squared and a 2. So 2e to the negative x squared. That's going to leave me with 2x squared minus 1. Okay, so now that I've got my derivatives, I want to find out the critical values. So for critical values, remember this is like max or mins, set y prime equal to 0. And to make this 0, remember this is always positive, so the only thing that will make this 0 is minus 2x. So x equals 0 is a critical value. And you can do a second derivative test to check, and you could do a first derivative test, but we have the second derivative here. So let's do a second derivative test. So I want y double prime when x is equal to 0. That's going to give me 2e to the 0 times, this is just going to give you 0 minus 1. So I'll put it as 2, 0 squared minus 1. So this is going to give you a number greater than 0 when x is 0. My goodness, I'm so sleepy, sorry. Okay, so this is going to give you 1, this is going to give you 2, and this is going to give you negative 1, which is going to make my second derivative negative. So if it's negative, then you have a maximum at 0. and I need to know the y-coordinate, so go back up to the original function, and e to the 0, e to any power, anything raised to the 0 is 1. My goodness. Okay, so now for points of inflection, we need to set the second derivative equal to 0. So if I set this to 0, I would get, what would I get here? Well, I already did set to 0. What makes this 0? Okay, so this can never be 0 on this side. So I want to know what makes 2x squared minus 1 equal to 0. So x squared is equal to 1/2, and x is equal to plus or minus 1 over root 2. So those are my x coordinates, and I'm going to do a second derivative test to check for concavity. So y double prime, and I'm going to have 1 over root 2 here, and I'm going to have my minus 1 over root 2, and I'm going to check values in each of these 3 sections to see if they're positive or negative. So if I go less than 1 over root 2, so what's 1 divided by root 2 anyway? Let's do that. Just over here on my calculator, I get 0.7. I should have known that off my head. Okay, so let's go to, let's check minus 1, and we'll check 0 here, and we'll check 1 on this side. So if I plug that into my second derivative now, if I put in negative 1 here, square it, so negative 1 squared is just going to be 1. E to the negative 1 is still positive, so that's all positive here. And this is still going to be positive here. If I square negative 1 times 2, I'd have 2 minus 1 is 1. So everything is positive. So that means in this section, we are concave up. If I plugged in 0, you can see that this will make this negative. This is still going to be positive. So I have concave down here. And you can imagine we're going to have the very same thing on this side because we're squaring things. So this will be positive and concave up. Okay, so that means we have points of inflection at minus 1 over root 2, and I need the y-coordinate, and 1 over root 2, and I need the y-coordinate. Now remember that when you go to find the coordinates, you must plug them back into the original function. So when x is equal to, I'm going to put in plus or minus 1 over root 2 here because I'm squaring. My function is y equals e. Oh my goodness, there's a little squirrel staring at me out the window here. He just looked in. He's probably mad because I took away his bird food. His bird food, did you get that one? Okay, sorry, I got a little distracted. 1 over root 2, and I'm squaring it. Okay, so if I square this, I would have 1/2. So this is e to the negative half, e to the negative 1/2, which of course is 1 over the square root of e. So that's going to put that right up here, right? 1 over the square root of e and 1 over the square root of e. Okay, so we've done everything but sketch it. So I'm going to make a quick sketch for you right here, right now. That was really funny. That little red squirrel's been driving me crazy. He eats all my bird food all the time. And he's getting very bold if he's looking in the window watching me do math with you. I wish I could have taken a picture for you. It's kind of funny. Okay, so let's go to, let's say well, this is minus 1, this is 1, this is my x, this is my y. And I have a maximum. Where was my maximum? Right here. Maximum at 0 and 1. Okay, and I have points of inflection at 1 over root 2, so we said that was 0.7. So about here and 1 over e, so that's almost like a half. And there's the same one over on this side. We also have, I'll get out my lovely pink here for you, we have an asymptote here of y equals 0. So if you have a point of inflection, so we have to show a little change in concavity here, like that, and like that. So there's your change in concavity. Look, it's concave down, and then it's concave up. And that would be the graph of y equals e to the negative x squared. Okay, I hope you found this lesson helpful. If you have any comments or concerns, leave them for me in the comment section, and I'll be sure to get back to you. Make sure you've subscribed and tell all your friends about this, and especially some little grade 11s so that they can follow along next year with advanced functions and calculus and vectors as well. Bye for now.